Hello everyone, and welcome to the third session of the EESSI Happy Hour under the topic series of how to access EESSI. In the first two sessions, we covered how to access EESSI using CernVM-FS client. There we required admin privileges. In the second session, we covered how to access EESSI using the EESSI container script, where we don't require admin privileges, but we do need to have Singularity, our obtainer, and Git. In today's session, we will be covering other methods of accessing EESSI. For today's session highlights, I will first like to mention that the EESSI governance has been added to the EESSI documentation. As you can see it now under the EESSI docs, it covers policies, code of conduct, terms of use, steering committee, and more information. Maybe Kenneth, can you give us more highlight about this?
Yeah, so this is something we finalized just last week. We just want to make it clear to the community how this project is being run and how decisions are being made. If you look at the current steering committee, you'll see, at least the people who have been following the project, you'll see familiar names there. It's essentially the core team, let's say, of EESSI, including me as a lead currently for the steering committee. But then familiar names like Alan, Bob, Caspar and Thomas, so at different sites, and then backed by other people as well who are often mentioned here as alternatives, stand-ins, let's say, if they can't make the meetings. The first goal of the steering committee was to document the governance of EESSI. So if you click the governance link, Richard, that's actually the biggest document in this. That just explains the different roles we see in the project, what the people in these teams do, and how decisions are being made. So if things have to come to a vote, how is that done? What kind of majority is necessary for passing the vote, and so on. So we don't have to step through this in detail now, but people who are interested can take a look. And this is definitely open for feedback and suggestions. So one thing we paid very close attention to is how we'll make changes to the governance. So there's also a voting mechanism for that. And anyone in the community is up for bringing up things that they are not happy with in the governance that they would like to see changed. And this is discussed in the steering committee and voted upon later. So we'll make some more noise about this as well in the upcoming update meeting. Maybe have a short blog post on this as well. But yeah, we're quite happy that this is now fully documented.
Thank you, Kenneth. One thing I would also like to mention is that the session is recorded. So in case anyone has any concern, just let us know after the presentation is done, so you can ask questions freely. So the other thing I would like to highlight is the hackathon session in the wake of Euro HPC User Day 2025 on the 2nd of October. For those who have not yet registered, you can scan the QR code available on the screen to register for the session. And before going further with today's explanation about ways to access EESSI, I would recommend, whenever possible, is to install CernVM-FS. So the tools or the tricks or scripts, whatever we're going to call them, we're going to show today. It is always preferable to use the CernVM-FS installation, the native installation procedure we had in the first session. So the first method to demonstrate for today or to talk about is the cvmfsexec. cvmfsexec is for mounting cvmfs as an unprivileged user. So basically it has minimal requirements. You just need to make sure that the max user namespaces in your environment is greater than 0. The cvmfs exec has a couple of drawbacks. First, it spins up Fuse daemon inside your user namespace. So startup cost is high. It also has some limited functionality when compared to the CVMFS native installation, such as the caching, the geo-distribution, the quota handling. And one important thing to note here is that your mount exists only as the lifetime of the namespace or the session you're in. So as soon as you leave your session, the CVMFS mount for the repository you're seeking is lost. As you can see here, this has been covered by one of the blogs under EESSI. So there has been added a wrapper script which wraps around the CVMFS exec. And what it does, that it clones the CVMFS exec to a temporary directory, and then it makes the make dist, and it gives you access to the repository you're seeking. So by simply copying the script, which is under EESSI docs, under blog, and making it executable, you can get access to EESSI. And this is what we are going to see in the first demo we are running. So as you can see, this is a VM. I will show you that it has no CVMFS installed. So there is no CVMFS. And if I do ls/cvmfs, you can see there is no access to CVMFS. I will also show you how small this VM is. So basically it's 20 gig and it's minimal memory. It's 2 gig memory. And what I want to show you also is the CPU type. As CPU grep minus, it's grep minus I should be Haswell. Yes, so it is Intel Haswell. Now, all I'm gonna do is I will also show you the script. So it is cvmfs copy pasted from what I've showed you in the blog. And simply what I will do is /cvmfs exec. So what it will do is it will clone the CVMFS exec into a temp repository, and it will give you access to the EESSI repository. So now if you do a df, sorry, df minus HT, you can see that the CVMFS is now accessible. So simply by running this executable, I got access to CVMFS. And if I do ls/cvmfs software.easy.io, I can see the directories underneath. As we did in the first session, now what I'm going to do is simply source /cvmfs software versions init bash, and this script should give me access to EESSI with an optimized software stack that is best optimized for the CPU microarchitecture I'm running on. So if I run this script, as you can see, it's telling me that it has detected that I don't have any accelerators. It has detected that I am running on Intel Haswell. So it has mounted and made a software stack specifically built for Haswell that is the best optimized for my CPU microarchitecture available within the shell I am running. So now if I do module avail GROMAX, for example, same steps I did in the first and second session. I mistyped GROMAX. That happens during demos. Module avail GROMAX. And now, as you can see, there are several versions of GROMAX available. I can simply load and run them. Again, as a reminder, this is just as a test case you can use to access EESSI. This is not the recommended way to access EESSI. Furthermore, I will just simply leave the shell I'm in. So I will leave the shell. And again, I will try to access the CVMFS. ls/cvmfs, I will see that there is no cvmfs. So this tool made me access this cvmfs repository, specifically the EESSI repository, as simply by running the script. So this is the first method we covered for today. The second method we will be covering for today is how to use the CernVM-FS shrinkwrap utility. So the CernVM-FS shrinkwrap utility provides a means of exporting cvmfs repositories. These exports may consist of the complete repository or contain just part of the repository. The CernVM-FS shrinkwrap utility uses libcvmfs to export repositories to the POSIX file tree. This file tree can then be packaged and exported in several ways, such as squashfs, Docker layers, or even a tar file. So I will be also showing you a GitLab issue on the EESSI where we have tackled this case. So all you need for this specific case of running the shrinkwrap utility is a configuration file where you point which repository do you want to clone part or total of. You also need to have a configuration file where you specify which software or parts of the repository you want to have within this squashfs file. And finally, you run the tool. It requires sudo privileges, but keep in mind that you can run it anywhere, and then you can copy the output file to whatever machine where you want to run Linux machine where you want to run the EESSI. So as you can see here, simply by executing sudo cvmfs, using which repo I am accessing, using which configuration, and using the output file, you can run the script and generate the required file. So I will cover this also and show you an example about this. And for this run, I am basically on Lumi. Lumi is one of the supercomputers. Now, Jupyter is the first and Lumi is second. Correct me if I'm wrong. So within the Euro HPC systems, Lumi does not have access to CVMFS yet or to EESSI, but this is a work in progress, and this hopefully EESSI will be accessible on Lumi soon. So if I do ls/cvmfs, I can see that there is no access. It is true that this is a login node. So what I will try to do now is I will run a job just to get access to a compute node and show you that there is no access to EESSI there. So hope, yes, it should be fast enough. Yep. So ls first, let me show you what the node is. ls CPU grab, it should be AMD. Yes, this is an AMD CPU microarchitecture node. And if I do ls/cvmfs, you can see that there is no access. For now, I will leave the node again and go back to the login node. I will show you the file which I have created, the squashfs file. This should be, yes. So I have created a squashfs file, which is basically part of the repository, not the whole AMD repository or the software repository. As you can see, it is only 8.7 gig. The advantage of this is that it can be placed on any VM where you want to run EESSI. For that, I will be also demonstrating if I can show you here. I have different versions of, maybe it's easier to do star.cif. Yep. So I can make this Squash FS mountable within an Alpine container or Rocky 8 or Ubuntu. Basically, today I will be demonstrating of how I will make it available within Ubuntu because most of the documentation or within the documentation of Lumi they focus on Ubuntu containers. So simply I will run the same script I ran earlier. So I will run a job script. As you can see, I will use Singularity and then I will use the Squash FS image file which was created and mount it within the Ubuntu container. So doing that, I will execute this and yes, I'm now within the container and to see that cat slash etc LSP release. As you can see, I'm running Ubuntu container 24.04. I will also show you ls CPU grep minus AMD. It should be detecting an AMD, yes. And now I will also show you ls slash cvmfs. As you can see, or maybe we can do it like this. I have access to, this doesn't show here, but ls slash cvmfs software.easy.io. So as you can see, I can access the cvmfs software.easy.io, which I need in order to load the software available within the Easy Stack. So now, as we have showed up in the past example, all I have to do is source slash cvmfs software versions init bash, and this should load the optimized software stack for the architecture, CPU architecture I'm running on. Just keep in mind that I have chosen and I have made a subset of the repository available through Easy. So if I by mistake clone the wrong or copy the wrong software stack, for example, if I copy the ARM based software stack within here and try to load it, it will not run. So it is more like you are making the choice of which software stack to run. If I do this, simply I will see that it has loaded the Zen 2 software stack, which I made available in the Squash FS. And it should give me access. It also like detected there are no accelerators. There we have the Zen 2 CPU microarchitecture and more. Over you can see that it is already like trying to show some modules from Lumi. So the Crayon page, Graylib SCSI. So what I will do just to clean the environment, module purge and the module list. No modules loaded. What I will do as simple example from within the SquashFS file which I created, so module avail also. You can see that there are the also micro benchmarks, module load. I will try to load and run also within the container. And if I do MPI run minus MP minus N2 also bandwidth. So let's see if this runs. Yep, this is expected because I'm running within the container, but setting this should fix the problem. Again, this might not be the best optimization I am getting, but again, this is just a proof of concept to show you that using this method, you can get access to part or the full easy repository which you cloned. So as you can see now, it has loaded the OSU micro benchmarks and it's running some tests which I chose. again and again. This is only showing you that the software is accessible and it can run. Maybe if you are interested in more of the tuning, you can join us the next session, which covers a bit more details of how to tune easy to better fit your environment or the system you are running on. So as you can see, the software is running and some numbers are showing up for the bandwidth test. So basically, this is all what I wanted to show you for today. I hope the two methods I showed were interesting. They are a simplified method of how to get quick access to easy. And again, as I said, for the next session, we are covering some practical considerations and recommendations for accessing easy. So for those who are interested in performance or some more tunings, join us the next session. So for now, I will end the presentation and we are open for questions, sharing ideas, any notes, tests and from anyone. So
Yeah, we'll keep the recording running for a bit longer,
mhm.
but we'll also close the recording at some point. And if you have more, let's say, interesting questions, they're definitely welcome at the end. I'm not sure if anyone here has any comments or questions that you want to raise, either vocally or via chat. Even on topics not directly related to this, you're definitely welcome to ask questions.
So as Kenneth mentioned, the Easy Happy Hours, it is true that we cover a topic for a session theme, but we are open for any questions related to Easy. And this is the point in sharing the experience, ideas for Easy from within the community.
I have a question, maybe as a bit of a teaser towards next week. So you've now covered native installation of CernVM-FS, which is the recommended approach. Last week you've covered using an existing container image that includes CernVM-FS itself, so a very lightweight container, but then you need Aptainer and fuse mounting and all of that. And now we've showed two other things, cvmfsexec and creating a squash image or similar, like exporting part of Easy into a file using that. Does that cover all possible situations? Or are there still situations where things may not work if you're using one of these approaches?
Mm, those are approaches which we have like mentioned in the blogs in one of the GitLab issues, but there are definitely other ways to access easy. For example, what I can share is that on one of our systems, we are exposing easy using NFS. Um, when you don't use the recommended way, you might run into unknowns. So, for example, since you asked this question, last week we ran into an issue which wasn't expected, and we tried to troubleshoot, and then we figured out that the NFS sync was out of sync. So basically, we are not syncing continuously on daily basis. So there has been some changes within the Easy repo, and those changes then got updated with fixes. Those fixes were not included in the sync with it, and then we ran into unknowns. So that's why it is always recommended to use the native CVMFS installation.
Mhm.
But other ways, yes, do exist, and we are open to hear from the community. Maybe they have still more ways.
Yeah, or more problems to work around, right? One of the reasons, like you mentioned, Mare Nostrum, Easy is already available there. What looks like natively on the system, but also there it's through an NFS export essentially from somewhere else. And the same approach will probably be used on Lumi as well, because they have some restrictions on in terms of what they can or want to install on the node. So they don't want to have the CernVM-FS client on every node, at least not initially. And then going through NFS is an attractive option, but like you said, it comes with downsides in terms of syncing and maybe other problems pop up. So it always has some effect on user experience or performance or something like this. Yeah.
One
Yeah.
thing we can add into this, when we are using the squash.fs file, you don't need internet access. So that's one thing maybe I forgot to mention. This could be interesting for system administrators who don't allow internet access on compute nodes or on the system. They need to keep up with creating those image files because it is not updated automatically. But again, it is a mean to get access to easy in a way or another.
Yeah. Richard, I have a question.
Yeah.
Yeah, so it's in the context you mentioned Lumi, and in the context of the previous question, one of the things I'm thinking about is since Lumi is a Cray system, could you comment on the possibility of accessing EESSI? Let's say, for instance, talk about OpenMPI, where OpenMPI could access the Cray lib fabric. Could you comment a little bit on that?
Um, Although we're stepping into the next week's session because I wanted to cover like more tunings, but uh, within our last, or at least my attempts, I can confirm that I am able to run OpenMPI on Cray system. For the time being, now we are going to do too many subjects, like covering also the compat layer version, because within our compat layer version 2023-06, we use OpenMPI 4.x. Like when we want to use a lib fabric which covers the CXI and Slingshot, we need to use the Fabric 2.0 and above, which basically is more compatible or at least proof tested with OpenMPI 5. That doesn't mean that there are no workarounds because we are already using, I can confirm that we're using this approach and running the easy stack on Cray system with Slingshot. But again, when we use the 2025.06 compat layer, which is basically will be based upon OpenMPI 5, things should be simpler and clearer. And integrating with libfabric from Cray, as you said, with OpenMPI 4 for the stack that already exists, at least I couldn't do that, integrate with libfabric from Cray, but I was able to build libfabric on top of Easy and then use that libfabric. And within performance, it's more or less close. Definitely, the libfabric from Cray overperforms what the test case I ran into. But at least this is what we have for now, and there is work in progress. So as soon as the new compat layer is around with the new stack, we can further discover things. Maybe Kenneth, if you want to add something on this.
Yeah, we're actively working on getting things in place there with like you said, on top of OpenMPI 5. So we're running into some issues with those builds, and we're figuring this out. Or like one open question we have is how we'll configure OpenMPI. We'll probably enable support for IPv6 IPs because some clusters internally use IPv6 rather than IPv4. So if you want to provide an open API that's compatible with that, it has to be configured like this. So we're now making those final considerations, and very soon in the coming days, we'll have OpenMPI 5 and stuff on top in place in Easy as well, in the new Easy version, as Richard mentioned. So it's 2025-06 rather than 23-06. And from that point forward, yeah, you'll have not only recent OpenMPI, but recent other software versions as well. And it becomes a whole lot more feasible to play with the Cray slingshots. So for Lumi, for example, this would be really interesting.
Maybe we can mention that on AWS, there were efforts, and we integrated with libfabric from AWS. And this is mentioned in one of the blogs. Maybe this is interesting for you, Hisham. to look into. So we were able to use the libfabric from AWS using the host injections within our OpenMPI for the 2023-06 Easy Software Stack.
Could you please share the link about the one you mentioned, AWS?
Yeah.
It's open. Thanks.
Do we have a blog post on that, Richard? I don't remember this.
We definitely have a GitLab issue.
Okay, yeah, maybe it's that. I don't think we have a blog post yet, but it could be a blog post for sure. And definitely when EESSI is available on Lumi, we'll probably make some noise about that with the blog post and probably how to get it running on Gray Slingshot with the new EESSI version. So there's a whole lot of things coming together then. The new EESSI version, EESSI being available on Lumi, and being flexible enough to have Slingshot support. So we'll probably write a dedicated post on that. I don't think we have a blog post yet, and I'm not sure about the support issue.
For the AWS, you mean?
Yeah. Can you find it, Richard?
Yeah, let me search. It should be there somewhere.
Is it? No, we have an issue on Slingshot support for Gray systems. Must be in there, right? Yes, okay. So 138 is the one. I'll drop it here in the chat, Isham. That's the one probably that has all the information that Richard was mentioning.
And Hisham, if you're more interested testing something, want to share with us, we are open. So if you check the GitLab issue Kenneth has shared, maybe try something, join us next week. Maybe you share your experience. We can further help you look into something or, yeah.
Yeah, for sure. Thanks.
Any other questions or comments? EESSI in general. You're definitely welcome. Maybe this is a good time, Richard, to wrap up the recording.
Yes, so
for today's session.
Yes, so for now, I will stop the recording.